Hello everyone, today we're working on 8.5 part 2. This is the assignment for Friday, April 17, and the homework is page 456, 37 to 41 odd, numbers 45, 47, and 69. Alright, let's get started. So the first problem we'll be working on is using characteristics to graph and write quadratic functions. So we're going to use the zeros to graph this function right here. So first thing we're going to see here is, what form is it in right now? Is it an intercept form, is it in vertex form, or is it in standard form? It's in standard form. And since we know that it is in standard form, we know that standard form always helps us identify what our y-intercept is. In this case, try to figure out what the y-intercept is, if there is one. Right here, it says -3. And this is going to be our y-intercept. Let me circle that. Y-intercept. So we have one of our points already. So that y-intercept is going to be written as x comma y, or also known as 0 comma -3. So we already have one point right there. That's going to be really useful. So now we're going to take a look at our graph again. So we're going to make a couple more observations. For example, we look at it, we have h of x is equal to x squared minus 2x minus 3. If we look in front of the x squared, where a would be, here nothing is written. So we automatically assume that it is 1. Is that 1 positive or negative? If it's positive, then the parabola is going to be, let me write down over here. If a is greater than, not greater than. If a is positive, then the parabola will be facing up. If a is negative, then the parabola will be facing down. Let me write that a little better. It'll be facing down. And here we have +1. And since it's positive, our graph should be facing up. That's useful to know so that when we graph later on, we can go back and check and make sure that it is facing up. So now we need to use the equation to graph it. So we already have 1 point here, but we need at least 3 points to graph a parabola. And so we notice that this function here is factorable. So we're going to need to convert it into intercept form. And by converting it to an intercept form, we'll be able to get a few extra points to graph it. So what we're going to do here is, let's go ahead and factor this. Y equals x squared minus 2x minus 3. You can use whatever format you want to figure out what the factors are. When we factor it, we get y is equal to x plus 1 and x minus 3. Alright, so now, can we use this equation to figure out what points we can use for our graph? Well, this is an intercept form. Since this is an intercept form, let me write that down right here. Intercept form. This means that we can use this to find out our x-intercepts. This time it's not the y-intercept, it's the x-intercept. So to find that, we need to set our y to 0, because that is what an x-intercept is. An x-intercept is when y is equal to 0. So then we figure out that what our x's are equal to, right? X plus 1 is equal to 0, and x minus 3 is equal to 0. And here we got x equals -1 and x equals +3. So those are our x-intercepts. So let's go ahead and start our graph now. Let's see. Where'd it go? All right, let's get our graph in here. Let's see. We'll do it right over here. All right. Go ahead and make your own graph at the same time. Okay. This is our y, and this one is our x. Okay, and we're going by a scale of 1. Okay, so we had one of our points was 0, -3, so let's go ahead and plot that. So 0 is our x, and this is our y. So we're not going to move right or left since our x is 0, and we're going to move 3 down. 1, 2, 3, because we have a -3. All right, there's one of our points. And we have a few other points here. We have x equals -1 and x equals 3. So how are we going to use this? This is not in coordinate form right now. So we're going to have to convert this as a coordinate. And remember, since it's x-intercepts, that means our y's are 0. Remember that we set y to equal 0 here. So that's why I'm plugging in 0 right here. So -1, 0. Let's go ahead and plot that. -1 and 0. So we don't move up or down. It's going to be right here. It's our x-intercept. And our other point is not negative, 3, 0. So 1, 2, 3. All right, and now we're almost done here. Let's see. So now let's look at these points. We know that these are x-intercepts. How can we figure out what our axis of symmetry is based off our x-intercepts? Take a second to pause the video and look at yesterday's lesson. That will be really important to help you figure out how to solve this question right here. So hopefully you got it. We can use this formula over here to figure out what our axis of symmetry is. P plus Q equals 2. Over 2, I mean. Or another thing you can do is we can count up, which is the same thing as what we're doing. How many points away are there? 1, 2, 3, 4. So where would the half point be? Well, 4 divided by 2 is 2. So our half point would be right here. So that means if we go 2 to the right, if this is 2 spaces away, this should also be 2 spaces away. So here we're going to create our axis of symmetry. And wherever our axis of symmetry is where our vertex is going to be. And we can get another free point right here right now. Since we know that this is our axis of symmetry, and the axis of symmetry is and the points will reflect off the axis of symmetry, if this is 1 space away, this will also have to be 1 space away right here. So we have another point right here. And now, all we need to do is find the vertex. Once we find the vertex, we will find the last point, and then we're good to go. Okay, so how can we find this vertex though? Well, what we can do is use this axis of symmetry. We know that the point's going to be right here, and there's only one point on this line, right? This one's just a dashed line to show where it reflects as the axis of symmetry. So to figure it out, we're going to plug in this point, which is +1. Let's go ahead and get our equation back in here and erase some of this stuff. Right. So we're going to replace all of our x's with what? We're going to replace it with 1. So let's do that. Oh, let me erase this as well down here. If you need any of this information, you can scroll back to the video. Okay. So y is equal to, we're going to replace the x's with 1, 1 plus 1, and x minus 3. Oh, not x. Should have written 1. 1 minus 3. So 1 plus 1 is 2, and 1 minus 3 is negative 2. And this is going to give us negative 4. So that means our point is we plugged in 1 for x, and we got a y value of negative 4. And this is our vertex. And this is going to be, let's figure out where 1, negative 4 is. So we go 1 to the right and 4 down. 1, 2, 3, 4. So right here. Oh, wrong spot. All right. And now we can connect the dots finally. Okay. It's a little messy. All right. And that's what our graph would look like. All right. So now, let's see here. So to summarize, use the information that you have. So for example, look at the a value, look at the y-intercept, and convert it back into intercept form to figure out the points. And notice that earlier we were talking about what the a value was. Our a value is positive 1, which means it should be facing upwards. And this graph is definitely facing up. So that means we at least have it in the right direction. All right, let's try another one. And here's a clear version of the same graph. Okay, so another one we're going to try out is write a quadratic function in standard form whose graph satisfies the given conditions. And our vertex, the only piece of information we're given is that our vertex is negative 3, 4. You might think, what are we supposed to do with that information though? Well, if we know that the vertex is negative 3 over 4, negative 3, 4, do we know a formula that we can use to plug this information in? Yeah, we do. We learned about the vertex form. Go ahead and try to write down the vertex form by yourself. It's pretty useful to know. You will be using it in future in like Algebra 2. Vertex form is written like this. Ax minus h 2 plus k. And the points that we have are negative 3, 4. So, which of these variables would correspond right here? Could it be a, x, h, or k? Well, when we write a vertex form, it's h, k. So that means negative 3 is h and 4 is k. So let's go ahead and plug that in. X, and our h is negative 3. So let's plug that in. Oh, I made a mistake here. Remember, be very careful with the parentheses. And then our k is positive 4. And now we need to simplify it. So we have a, and our a in this case is just going to be 1. You can make it whatever you want, because as long as the vertex is negative 3 over 4, you're good. All right, and then we leave x. We have here not a negative times a negative 3. This could be seen as negative 1. So negative 1 times negative 3 would be positive 3 squared plus 4. And notice that you might think that we're done, but it asks us to write it in standard form. If we're going to write in standard form, that means we're going to have to find the product of x plus 3 to the power of 2, which is going to equal x squared plus 6x plus 9. Am I missing anything in here so far? Yes, I'm missing that plus 4. So now we can simplify this and combine like terms. 9 plus 4, 13. And that would be a function that represents the vertex that we're provided with in standard form as well. So we're going to try another problem like this. In this one, we're going to write a quadratic function. Oh, let me fix this. In standard form, whose graph satisfies a given condition, passes through negative 9, comma 0, negative 2, comma 0, and negative 4, comma 20. So before we start this, you might be a little overwhelmed looking at this, but pause this video if you can and try to see if you can find anything special about these points. Remember that if you're given coordinates that have zeros in them, right, then those are going to be what? They're going to be x-intercepts and y-intercepts. See if you can identify any x-intercepts or y-intercepts in here, because those are going to be really useful in creating an equation. All right, hopefully you paused the video and figured it out. Well, if you look at this, we know that this one, and this one are x-intercepts. And this is extremely useful to us because there is actually a formula that we can use for this as well, the intercept form. Hopefully you can write this equation down by yourself. If you can't, I'm about to write down. If you can, try to write down, but pause the video. X minus Q. All right, so now we're going to replace the P and the Q with our x-intercepts right here. So we're going to leave the A because we do not know what our A is yet, and P, we're going to replace it with negative 9. And then x minus Q, which is negative 2. And now we're going to simplify. Negative times negative 9 is positive 9. And a negative times a negative is also positive, so it'll be x plus 2 now. And now, once again, the question asks us to put it in standard form. So when we go ahead and you can factor it, you can FOIL it, whichever method you like, but hopefully you get the following answer. Actually, before we do that, we're going to do something else. We need to figure out what A is first before we factor it, but not factor, before we FOIL it out. All right. So how can we possibly figure out what the A value is? Well, remember earlier we were given other points to use. So if we plug in those points, we can figure out what our y is. So let's go ahead and use this one point that we didn't use, negative 4, 20. So what this means is if we plug in negative 4 for x, our answer should be 20. Oh no, and that's not what I mean. Sorry. If we plug in negative 4 and 20, we'll be able to figure out what A is. So let's go ahead and do that. I'll write it down right here, -4, 20. So this is our x, and this is y. So we're going to replace y with 20. We're going to leave a alone, and we're going to replace all our x's with -4. We know this point is on the graph, which is why we're able to do this. And by doing this, we can figure out what our a is. Now we're just going to simplify. -4 plus 9 is 5. -4 plus 2 is -2. And now we're left with a times 5 times -2. 5 times -2 is -10, and times a. Now we need to get rid of this -10, so we divide both sides by -10. And we're left with a is equal to -2, right? 20 divided by 10 is 2, and we have this negative, so it's -2. So we're going to take this information. Now we know that a is -2, and we're going to plug it back into this original equation right here. Let's go ahead and do that. Let's rewrite it. Y is equal to -2. We're going to keep everything else exactly the same. And now we can distribute it and figure out what it looks like in standard form. And when we do that, you should get -2x squared minus 22x minus 36. All right. And oh, there's one more for today. Okay. Now this one is a little scary also to look at. It says the graph represents a cubic function. This is what a cubic function looks like. And it asks us to write the function. How are we going to do this? Well, once again, let's look at our graph and observe the information that we're given. We're given 0, 0, 2, 0, and 5, 0, and 3, 12. See if there's anything useful in this graph. Pause the video and hopefully see if you can remember anything. It is similar to this question, so if you're struggling to figure out what the similarity is, go back and watch the beginning of this video to see if you can remember anything that might help with this. Okay, so notice that we have zeros right here, right? All the y's are 0, which means all three of these are x-intercepts. Knowing that, there's a handy-dandy formula that we can use for this as well. Alright, so for this one, knowing that we have the x-intercepts of 0, 2, and 5, we can put this in intercept form. This is what it's going to look like. F of x is equal to a times x minus p, x minus q times x minus r. So now, we're going to go ahead and replace each of these with p, q, and r. So this one's going to be p, this one's going to be q, and this one's going to be r. So let's do this over here. So we're going to leave a alone once again, and leave the x alone too, right? And we're going to plug in for p. So our first one was 0, so x minus 0. Our next one is 2, so we're going to do x minus 2. And our last one is 5, so x minus 5. Once again, are we done yet? No, we're not done yet because we still have this a here. So that means we need to figure out what our a is equal to. So let's, instead of f of x, let's write y for this. And now, see if you can try to do this by yourself. let's use this other point that we're given and plug it into the equation. Remember, 3 is the x, and 12 is the y. Okay, so we're going to plug that in. We're going to replace it. So 12 for y, leave the a alone because that's what we're trying to figure out. And we're going to replace the x with 3 on the whole entire thing. Replace all the x's with 3. Alright, now we just need to simplify this. 3 minus 0 is 3. 3 minus 2 is 1. And 3 minus 5 is negative 2. 3 times 1 times negative 2 is negative 6 times a. So we now divide this by negative 6 on both sides. 12 divided by negative 6 is negative 2. And that is our a. Wow, it's the same as last time. Negative 2 for a again. Okay, so we're going to take this negative 2 that we got for a and replace it in here. So let's rewrite this. I'm going to write it over here. So our equation is going to look like this. Y equals negative 2 times x minus 0, x minus 2, and x minus 5. I have some computer issues. Okay. And now we're going to go ahead and put this in standard form as well. So when we put in standard form, it'll look like this. Negative 2x to the power of 3 this time, right? Because we have 3 x's. And for this one, it might be useful to use the vertical method. You can also use the FOIL method, though. And that's it for today.